All right, welcome everyone. Hope you're, enjoying the day, the conference itself. So let's start. I do remember with, great anxiety when I had to work on an old banking product. It was COBOL stuff. At the time, I was a young software engineer. I was full of energy and willing to learn new stuff. But let me tell you, that was not fun at all. The code base grew over the course of the past few years. Actually, I'm cheating because that code base grew over the course of the past few decades. I'm not that old, but there were code lines that were actually older than me. Every day, I used to count every single minute till the ring of the bell, and when finally the end of the day came, I had no energy to do anything else. There were only a handful of people who actually could understand what was going on there. And every day, there were fewer and fewer of them. You may ask why. Well, because every day someone retired. And don't let me even start about testing or deployment practices. I think that's good material for another time, maybe next year. That was a legacy product, and these are only a few examples of how legacy actually affects developers from all over the world, let's say. I'm Marco. I'm a senior software engineer at Klarna, and today I won't talk about COBOL, unfortunately, even if I bet everyone in this room would love to learn more about it. Instead, I'll talk about how me and my team killed a legacy product and successfully migrated to a new solution. Welcome to Killing Dinosaur, a migration history. Before diving in, let me tell you a couple of stuff. Yes, I know decommissioning is not always doable. Of course, the costs of such projects are one of the most relevant drivers here. Even if technically almost all decommissioning and migration are possible. Almost possible. The second point that I want to make is that, of course, I want to talk about the approach that we used, and this approach was tailor-made in a way for our use case. But as everyone faced legacy products in his working life, I think that a lot of you can actually relate a lot with the situation and what we did. And so hopefully you can grab some takeaways. So if you're a developer, then you'll see how the Dinosaur subject of this story was, how it grew over time, and how we approached the decommissioning. On the flip side, if you happen to be a manager, then you'll see how legacy actually impacts the team in terms of performance, of course, but also in terms of costs. The most obvious being the maintenance cost, of course, but also cognitive overhead and turnover. This will be the agenda. So I'll start by showing you the actual dinosaur that is called Katch, that was called Katch, actually, and show you how it grew. Then I'll talk about the issues we had with it and why we decided to migrate. Afterwards, I'll start talking about all the nitty and gritties of the process, of the decommissioning process, of course. And yeah, finally, I'll talk about drawbacks and issues we are having right now after the decommissioning, and then wrap everything up. So let's start. What was Katch? Good question. I thought that, at first I thought that, showing some pictures of it was a good idea. But actually, I've looked everywhere, and all relations to Katch seems to be disappeared over the internet. So the only image I found was this. I hope you can see something. This was one of the images that our users used to send us through Slack to help us with the debugging. So I think this starts to give you a good grasp of what we are going to talk about. Jokes apart, Katch at the beginning was an internal tool used to review suspicious order. I don't know how many of you are aware of what Klarna does. Basically, Klarna is most known as a BPNL provider, that is buy now, pay later provider. So we have to, manual review also orders flowing in the systems. And Klarna, as a company, offers a bunch of payment options. We have the pay now, the pay later, the pay in X installments. And to prevent frauds and minimize losses, this tool was created and used by the so-called fraud agents. So kind of clear, right? This tool is doing just one thing. All right. But then someone asked for a way to, block fraudsters directly from Katch. Fair request, right? So yeah, let's do that. Later on, after some time, someone else asked to provide some sort, of blacklisting of suspicious orders. So for example, when you identify a fraud, you could mark as risky an attribute of the order or of the user. So like the email or the address or whatever you want. Another fair request. Let's do that. I think you may start understanding where I'm heading. So after it came the so-called SLA enforcer, and then the pending flow, and then the batch layer, and then the account sign-up verification. You can name it. Katch became like a bin in which to throw everything that was vaguely related to frauds. And at the end of the journey, here's how Katch used to look like. All right, nice. So this is called the octopus diagram, by the way. You may wonder why. Actually, I've cheated it a little bit because actual Katch is the box in the middle containing all the blue boxes inside. But, I mean, you get the idea. Let's move on. Kind of obvious, but let's talk about what's wrong with these. First of all, the scope of the system is just wide. A lot of stuff stuffed in a single place for a single team. A lot of different scenarios were there in the Katch ecosystem, and actually there's a clear lack of product vision. The product was clearly going nowhere, trying to cater to too many different use cases. And also, a lot of these features were actually done by other teams in other products. It was just more convenient to have all there in Katch. I imagine how many times did this happen to you. All right, let's go technical. And let's talk database. So when Katch was born, it used to have a relational database. Let's call it real-time. All right? It was a MySQL database, and the data were coming mainly from two sources. The first one, of course, the user inputs. The second one, the events ingested from Kafka topics. We do a lot of Kafka in Klarna. The team soon realized that a lot of the data saved in the database was just incomplete. Every time our users tries and ask for adding a new data point in Katch, the team was in pain. To try to solve this incompleteness, the team decided to add a new database. Let's call it batch. This was populated, of course, by batch jobs. Batch jobs were just ad hoc scripts that the team used to write and run to gather missing data points from somewhere. Also, another pain point was that at the end of the Katch journey, adding an index, a simple index, to the database was just a pain in the ass because it required at least 1 week of full computation. As I said, we do a lot of Kafka. We have a lot of Kafka in Klarna. And such a simple thing like adding a Kafka topic, so a new data source to Katch, required to the team at least 1 month of work full-time. Maintaining Katch was also super expensive. We are talking about $25K a month. And also, the financial impact that the company had when Katch has an incident was huge. And we used to have an incident like once every 2 weeks. Talking about incidents, let's talk about human cost. So we're talking about frauds. So the team needs to act as quickly as possible whenever an incident arises. So think of the pressure the team had to undergo to keep Katch up and running, constantly firefightings. Also, because of this, the turnover in the team was really high. And of course, turnover high, little to no handover. Also, last point would be the cognitive overhead. So imagine to start in the Katch team tomorrow and have to learn all the stuff that I showed you before. Well, why we decided to migrate, if that was not enough? To make a small recap, we have a team in a tough situation, left with maintaining a tool with scalability issues, questionable database design, and high maintenance costs. The management was also worried on several fronts. Hard to hire and keep people in the team, costly to maintain the system, but also necessary because there was no real alternative. Back in 2019, Klarna started its expansion to a new market that was New Zealand. New Zealand was kind of small with respect to bigger markets in Klarna like Germany or Sweden. So we took the plunge and decided to rewrite Katch from scratch. And please, join me in welcoming Skan. Yeah, that's Skan. You may say that nothing really changed because, you know, boxes, arrows, like before. Actually, that's not true. But yeah, I'll go through every single piece of this architecture shortly. Right, do you know these guys? So I don't know if you ever heard about the Philadelphia 76ers. It's one of the teams in the NBA Eastern Conference. And back in 2013, they started the so-called process. I'm not an expert here, but basically the team was like stagnating. They didn't manage to win anything. And so they started out of the blue to, you know, looking for young talents and destroying the old team. I like to think we did something like that. We had this big product that used to work, but we decided to start from scratch as well. The only difference is that they are not winning anything right now, while we are successfully in production. All right, so the first step here is the hardest one, honestly, at least for a technical person perspective. That is deciding with the stakeholders the scope of the new solution, or also deciding the vision of the product and try to stick to it. Of course, we wanted to provide something useful as soon as possible. So we decided for the bare minimum number of features that was, of course, the possibility of reviewing suspicious orders. Yes, it is the reason why Katch was born years ago. From there, we kept our feedback loop short and sweet by iterating over the solution really quick. Of course, bi-weekly demos made our life way easier and you know, helped a lot staying on the right track. Also, our stakeholders were amazed about how the team velocity was in terms of delivered features. All right, let's now talk about something really interesting, finally, the technical stack. It may look like it's an AWS commercial, but it is not. So, as I said before, yeah, we use a lot of Kafka, again, in Klarna. And by a lot, I mean really a lot. Basically, all the communication, the asynchronous communication between systems in Klarna is done by sending and consuming Kafka events. So the scale can vary, of course, from events to events. But in general, it's quite high. We can expect for some of them thousands of events per second. So we needed something that's always up and running, and that can scale, of course, and that can integrate well with Kafka. For these reasons, we thought that ECS, the managed container solution from Amazon, with a Dockerized Spring, Java Spring application would work well, and actually it does, because ECS provides scaling. We don't need to worry about it. And of course, we are also able to fine-tune the number of instances that we want based on the period of time in which we are. Java Spring also integrates perfectly with Kafka. So this is just a small part of the system. You can think about Skan as of three main pieces: the ingestion, the serverless ingestion, and the serving itself. So the system is quite loose coupled. So the Java application basically reads events from Kafka and syncs them into storage. Right, but which kind of storage? There's a spoiler here, DynamoDB, but yeah. This choice was actually interesting because being on Amazon, on AWS, we had a bunch of possibilities, relational, non-relational, columnar, you name it. We went with DynamoDB, of course, because of a bunch of reasons. The first one is, again, that we wanted something that was managed. So we didn't want to mess up with instances, clusters, replicas, shards, whatever. We wanted just something that actually worked. You may say, yeah, there are also relational managed services. Yeah, you're right. But in this case, we wanted to leverage the freedom of key value storage like Dynamo, given that Kafka events are, by definition, let's say, semi-structured data. Also, we went with DynamoDB for another great feature that are the DynamoDB streams. A DynamoDB stream is nothing but an order flow of information about changes in items in a DynamoDB table. So basically, it's a AWS NoSQL version of good old database trigger. This feature is particularly interesting because it allowed us to asynchronously enrich and transform the data we ingested. Okay, this is the asynchronous ingestion, and as you can see here, the DynamoDB stream is used to transform and enrich events by calling other services. We also do another interesting things here, that is transforming data and put it into an ElasticSearch cluster. Why? Two reasons. Because, of course, the search capabilities of ElasticSearch are, of course, great. And these allow the web application to search directly on Elastic instead of hitting the database. Also, another good pro is that the front end can now create its own query without waiting for the backend to be ready. It's not a win-win, actually, but I'll talk about the drawbacks later on. So all this part is done in AWS Lambda, reason being the automatic and virtually infinite scale that allows us to cope with different types of loads. Of course, it's not that easy, but yeah. Intercommunication, of course, between lambdas is done via SQS and the related DLQ. SQS is the AWS solution for queue. Another interesting thing here is that fan out lambda there. One limitation of DynamoDB streams is that you can attach at most 2 lambdas to the streams. So as you can see, we have the need to attach more than 2 lambdas. So this is a pattern that we decided to use. Basically, the DynamoDB streams goes into this fan out lambda. That lambda is a really dumb lambda that just grab stuff and place items into different queues. All right, let me talk briefly about the web application as well. I can't say much about the front end, usual stuff, TypeScript, React, S3 buckets. That's pretty much it. But how do we serve data? At the same time, as before, we make use of AWS Lambdas. And in particular, this part is done in Python because at the time the team was basically composed only by Python developers. Also, of course, we expose APIs through the Amazon API gateway. All right, we went through a bunch of stuff, right? To recap, Docker, Java, and Spring to ingest data from Kafka, DynamoDB and Elasticsearch for persistence and search capabilities, and AWS Lambda and SQS to to easily scale the system. So in a way, we can say that, yeah, the new market is up and running. That's cool. But are we missing something? We are. What about the existing markets? We are talking about frauds again. So historical data is kind of important here. So we decided to release Katch and Skan with Katch in parallel in all markets with all the same set of functionalities. The idea was to let the new and the old product run in parallel and let our users use both of them, because we kind of use Katch as a benchmark for the new solution, Skan, and also, of course, to make sure that we didn't mess things up. Once the feature parity then was reached, then we could, shut Katch down. Talking about frauds, historical data. So this means that we had also to migrate all the data present in Katch to Skan. You might say, yeah, easy, just, perform a query and just transform it and sync it into the database, into Dynamo. But it's not that easy. Of course, the difference in the technology is a first problem here. We pass from a relational database to a NoSQL solution. Also, we had in mind to migrate only a batch of data per time, like to validate our data. And we wanted to do that by timestamp, so like 1 month at a time. So this was impossible because indexes, as I said before, were basically impossible to add, and the timestamp were not indexed at all. Also, the Katch database is not reliable, so it's not a trustful source of data. So what we can do here? Well, the idea was to look for elsewhere for data sources, and in this case, we looked for raw Kafka events. Luckily for us, in Klarna we have a lakehouse built on top of AWS Redshift. And basically what happens is that data goes in Kafka, then it's exported to S3 bucket, and then transformed and synced into our lakehouse. Because the syncing, the step between S3 and the lakehouse involves a little bit of transformation, we decided to just go to the S3 buckets and pull the data from there. All right, but then we we have billions and billions of rows. So how we safely move data from S3 to DynamoDB? We needed horsepower for that, and possibly, and for the third time today, we needed, a managed solution for that. Thank God AWS Glue exists. My team used to say this all the time back when we started migrating. But what's Glue? Glue, again, is a fully managed ETL service. So it's not, of course, the core of this talk, but I think it's interesting to understand what it is. So Glue allows you to use Spark or PySpark scripts, in our case, PySpark. It connects out of the box with multiple data sources from Amazon. It's free, Redshift, all the database that Amazon offers. You can then, of course, with Spark and PySpark, create data frames, transform them, do whatever you want. And also, it can sync data basically anywhere. The cool thing is that Glue is serverless, so no infra required. You just have your script, and you put it in AWS, and it just works, hopefully. All right. Another interesting topic to me is the, let's say, the structure of the Glue jobs, or Glue scripts, or pipelines, whatever you want to call them. So every single Glue job was consisting of those 5 points. Yes. First of all, you, of course, have the part in which you grab the data from S3. Then, if needed, you have to filter it. Then you process the data. And this is the point in which every job is different one from another. And the final part is like split into different parts. If we want to, understand how reliable the migration is, then we validate the data sets. Otherwise, if you are, we already validated, we are sure that the data is good, then we just sync data whenever you want. Let me talk a little bit about again, the validation part, because it was kind of the core of the whole process, because as I said, it measured the reliability of the migration. So this step was used as a benchmark, and basically we sampled data from the processed dataset, and we compared it against Katch. Then we created a report, a PDF, with a number of metrics, excellent matches, partial matches, no matches, and then the list of what was wrong in the pipeline. Also, each step here is used to output the data into an S3 object, so that we could resume the pipeline from a certain point using the outputted S3. So without running the entire pipeline again and again. All right, that's it, we did it. Easy? Well, the whole process took 1.5 years of work about the team, from the team. Right, drawbacks, bunch of them. Okay, let's talk about costs. As I said, maintaining Katch was like $25K per month. Skan is just a little bit less expensive. We are talking about 1/3 less, more or less, but this was expected. We prefer to, however, spend money, but having a more, loosely coupled and modular solution. The main part of these costs are because of ElasticSearch. All right, DynamoDB. Tricky one. As all the NoSQL solutions out there, you have to choose your primary keys wisely. So you have to understand and know in advance all the possible access patterns that you have in your application. Otherwise, it's just a nightmare. Adding a different query is just a mess. And of course, it's virtually impossible to scan an entire DynamoDB table because it is just too expensive. All right, I briefly talked about it, but the thing that we have an asynchronous processing between when we save data and persist data to Dynamo to when the data is present in the Elasticsearch can cause some problems. The first one is that we may have missing data, of course, because from DynamoDB to Elasticsearch, there are a bunch of steps, and almost everything can break. So yeah, we can just have missing data in Elasticsearch, but this is acceptable. We have a SLA of 24 hours, so we don't strive to have all the data present in Skan real time. Also, of course, there's a chance of having inconsistent data. We are transforming data from Dynamo to Elastic, and of course, if a developer introduces a bug, then we will have wrong data into Elasticsearch, and then our users will see wrong data. The good thing is that, so it's not, the last one, it's not a drawback actually, but it's a good thing. The data is, however, persisted in Dynamo. And having SQS, Lambdas, and so on and so forth in place allows you to just replay the actions. And if a bug is introduced, then you can just fix the bug and then replay the operation. All right. Talking about Lambdas, I think that these drawbacks are like common to Lambdas, microservices architecture, and so on and so forth. So as the system grows, it's really hard to keep Lambdas consistent and small. And also, it is hard to manage them. Like, do we have a repo, one repo for Lambda? Do we have multiple repo for multiple Lambdas? How do you split them? How do you do continuous integration and continuous deployment on that? So it's kind of tricky. Also, there's an argument to be made on how you share code between Lambdas. Do you use libraries? Do you duplicate code? What do you want to do? All right, we're at the end of the journey. Closing words. So we covered a lot of stuff. We can pat ourselves on the back. So in this talk, I've showed you how Katch was, how it grew over time, and the pain points it used to have. I've also talked about the possible approach for decommissioning and migrating by starting small and creating an MVP and iterate over it. Also, I've guided you over the new tech stack and the architecture, as well as our data migration pipelines in AWS Glue. And finally, I talked about issues and drawbacks. Once a very wise man said that migrating is hard and not always doable, but when possible, try to make a plan, start small, and iterate. And I would also add that you have to try to keep the stakeholders in the loop and gather early feedbacks. Also, next time you have to face a monster like Katch, remember what's the only way to eat an elephant? It's just one bite at a time. Thank you.